Yeah, yeah,
Yes.
yeah.
Yeah.
Okay. So, sorry for the delay. Today was something I had to get segregated between all my classes. So, okay. Okay, fine. So let's start a small introduction, a quick introduction of Java. Okay. So you told me that you have a little idea on Java, right?
Yeah.
Yeah. So let's go to the history of Java. Okay.
Mm.
Okay. So what do you, as you know, Java is an object-oriented programming, right? So I want to ask you a small question. Is Java a pure object-oriented programming? Hello?
I don't know what you mean by pure.
Hello?
Yeah, I don't know what you mean by pure object oriented.
Okay, okay. So pure object oriented in the sense, like, what is an object? Object is nothing but which exists in the world, right? Physically which exists, right?
Correct.
So yeah. So the thing which exists physically, right? So in Java, everything is treated as an object. Okay. So for example, we have few OOPS concepts. Okay. I think you'll be knowing it. Okay. That is like inheritance, no polymorphism.
Mm-hmm.
Okay. And few things are there. Okay. That you'll be knowing it in further classes. But still, sometimes there is a question that whether Java is a pure object-oriented programming or no. Okay. So because what happened is in inheritance, multi-level inheritance is not done by Java. Okay. But still, multi-level inheritance is achieved through the concept called interfaces. Okay.
Mm.
So now everything is implemented by using object itself in Java. Whatever you implement, that is implemented through object itself. Okay. So I'll be teaching you how to create an object, how to create a class, everything. Okay. So using object itself, every concept or every logical things you are implementing. Hence we can tell Java is a pure object oriented. If anybody questions you telling that there is no multi-level inheritance in Java, hence Java is not pure object oriented, but still Java is pure object oriented since
Okay,
multi-level.
your voice is breaking up, man.
Really,
No, now it's
I'm
clear,
able
and then
I'm able to hear your voice very clearly, Shankar.
I know I'm able to hear your voice
So
clearly too, but sometimes it's breaking up. Maybe you are turning your face away from the mic.
me, no, mic is just right front of my mouth.
Oh, so anyhow, I have a question. So this
Yeah,
presentation, what you're having, at the end of the class, can you send it to me so that I can revise?
yeah, sure, we'll send it to you.
Okay. Yeah, you can continue.
Okay, yeah, we'll send it to you, not a problem. Okay, so yeah, so you got the point, no, pure object oriented programming in the
No,
sense.
you said you didn't mention whether Java was pure or object oriented.
I have mentioned, right, Java is a pure object oriented.
Oh, okay.
Okay, it's a pure object oriented programming. But what I have told a constraint that somebody will, I mean, if anybody questions you, because in Java there is no multi-level inheritance. Okay, so but still there will be a question like, since multi-level inheritance is not there, whether Java is pure object oriented or not.
No, but you
But
said
still,
interfaces are there to use that multi-level interface.
yeah, that's the reason. That's the reason I was telling you it's a pure object oriented programming.
Okay.
Because multi-level is achieved through the concept called interfaces, no? Hence we are not missing multi-level, right?
Yeah.
So we can tell it's a pure object-oriented programming, okay? And you know that Java is developed by Sun Microsystems and by James Gosling, right?
Yeah.
This is the one which everybody will be knowing it, right? So And the other thing is before the Java language was named as OAK, okay, in 1995, okay, 1995 it got renamed to Java, okay. So why it has got a name as OAK before is actually Java was developed by James Gosling under a tree called OAK, okay. Hence they have
Hey,
named
I
it
didn't hear you,
Java.
ma'am. Swati, I'm not
Sorry,
able to hear you. I'm not able to hear you.
one second. I'll reconnect it. One second. Right?
Okay, I'm not able to see your screen. Show me your screen.
Yeah, I have shared. You should be sure. I think your connection is somewhat slow. I have shared
No, no, no,
now.
no. Now your screen came up, but I'm not able to see the presentation. I'm seeing your desktop.
Desktop. How can that be possible?
Now it came up. Yeah.
What is there in my screen? It will be shown, right?
No, now it came up.
Yeah. Okay.
It is slow.
Yeah. Yeah. Okay. Good. Yeah. Yes. I think connection problem is at your end because if something connection problem, I would not be able to operate anything. My internet is 10 GB speed actually.
Hmm.
Okay.
What do I have to do? I have to buy a faster internet. Huh?
Yeah, you have to reason you're facing some disturbances of my Java name was before Java name was OAK and it was renamed to Java in 1995. Okay.
Yeah.
So, like what I can tell Java is like it's very flexible and it has many features like robustness, okay, and then it's flexible. It's very easy to understand, okay. It's like purely object oriented, okay, and it's very secure also, and it is platform the main thing is it's platform independent, okay. So you can write once and run anywhere, okay, because whenever you write a Java program and whenever you execute or compile a Java program, a byte code will be generated, okay. This byte code made Java to be platform independent. Okay, got my point, Shankar?
Yes.
Okay, so this is a very quick history of Java, I can tell you. Okay, let's see the what are the features available in Java. Okay,
Yep.
okay, so now the shown are the I'll make it full. Yeah, the shown the below the features shown on the screen are a few features available with Java, which I have already discussed with you just 2 minutes back. Okay, those are like Java is very simple and it's very easy for any lay person to understand. Okay. So like how can you tell it's very simple is, for example, when you write a simple Java program, a program will be divided it into like modules, okay. Like a class is one module and object is one module. So you can easily understand what is happening in a program. Okay, so I can tell it's very easy for any person to understand. Hence, it is called as a very simple and familiar language. Okay, and then next one is compiled and interpreted language. Okay, so what is this compiled and interpreted is nothing but, you know what is a compiler, right?
Yeah.
Yeah. So which will convert the high level language into a low level machine
Yeah,
level
but
language.
features of Java, why it is said compiled and interpreted? Because every programming language is have got a compiler.
Yeah, that's what I'm telling you. Because whenever you compile any Java program, okay, in none of the a speciality of this Java program is Java is like whenever you compile, it will generate a byte code. Okay, this byte code is a thing like which can be used anywhere. It's not like now, no, for example, let's take C language. Okay, in C language you can't it's totally a platform dependent language, right? You know that,
Right.
right? So Java is not like that. Java is purely platform independent, because when you compile a Java program, okay, the byte code will be generated. Okay, I'll discuss you with a pictorial diagram in the next slide, okay, about this, so that you'll get a clear picture on that.
Okay.
Okay, so for this slide, you just remember that it will generate a byte code which enables the Java thing to which made the Java which made Java feature like it's purely platform independent. Okay, that's like you can write once and then run anywhere in any platform. Even then your hardware parts are changed. Okay, so even then you can you can run this program, but whereas in structured programming or platform dependent, only in the specific thing wherever it has written, it has to be run there itself, right? So hence Java is called as platform independent. Okay, so and the third thing is object oriented. As I said to you, Java is purely object oriented. Everything and anything is Java is in the form of object. Okay, so through object itself we can easily get the results. Okay,
Yeah.
so hence it is totally purely object oriented program. Okay, and fourth one is which I was already discussing you when I was discussing with compile and interpreted. Okay, it's purely platform independent and portable. Okay, so this portable in the sense you can take that byte code and run in any machine, hence it is portable, right?
Right.
Okay. Yeah, and fifth point is robust and secure. Okay, what is this? How the Java has achieved robustness? Okay, so Java has a capability to fight against errors. Okay, like we had a concept called exception handling in Java. Okay, so this exception handling in Java deals with, okay, to fight against the errors. Okay, it's especially now in a very high level programs. Okay, when you learn from the basic without exception handling also you can write, but still whenever you write a very big programs, exception handling is a must, because even though if your program is not having any errors, if we include exception handling statements, then if at all in case if any errors are there, the compiler will fight against the errors. Okay, that is a specialty of Java. Okay, hence it is very robust. Okay, it
Okay.
can automatically fight against the errors. Okay, so and secure in the sense it's very secure, as like the byte code, right? Byte code cannot be understood by anybody, right? Until and unless you can run. Okay, it will be understood. Okay, but still how we can achieve secure is there are access specifiers. Access specifiers exist. Okay, like access specifiers enables the program to view the program to other people, or to hide the program, like that. So there are three access specifiers, that is public, private and protected. Okay, so public in the sense everybody can view the code. Okay, private in the sense it's very secure, nobody can view the code. Protected in the sense only some part of the code which is really necessary to show, that only will be visible. Okay, in this way your code will be hidden or visible or something. In this way we achieve security in Java. Okay.
Yeah.
Yeah, next, distributed and network oriented. Okay, so what is this distributed and network oriented is? Distributed in the sense, for example, there is one very big Java program. Okay, for example, yeah, For example, I can tell now we have to calculate the area of all shapes. Okay, a simple example I'm giving you. Now we have to calculate the area of different kinds of shapes. Okay, so now the Java program can be divided it into many parts and given to the other people, and later we can easily combine it. Okay, for example, now there are 5 machines in a computer laboratory. Okay, in machine 1 you're calculating the area of square, in machine 2 you're calculating the area of rectangle, and machine 3 you're calculating area of triangle. Okay, so now even though it is developed by different persons, it is easily distributed between people. Okay, and then it can easily combine through when our machines are connected to each other. Okay, so whereas in C language we cannot distribute a program, right?
Right.
Right. So because in Java, for example, in one machine if you write a class, in another machine if you write another class, in another machine if you write another class, it's one and the same. Only through objects we'll be connecting the classes, right?
Correct.
Yeah, if you write one object and access the third machine class also, it's fine, not a problem, right?
Right.
So hence it is called as network oriented. Okay. So that's how this feature has come to Java. Okay. And then 7th point is multi-threaded and interactive. Okay. What is this multi-threaded in the sense? For example, you'll be knowing in further classes what is a thread and all. Okay. So let me tell you what is this multi-threaded. Okay. Like I can tell multi-threaded in the sense, performing multitask at a time. Okay, like for example, a small example. Now when you go to a movie, okay, when you go to a movie, you have to get some tickets, right? So for example, if in a movie theater, only one person will be issuing a tickets to you, and the same person will be showing the seat inside the theater to you, right? So if only one person will be doing all these tasks, it will take a very long time, right? He has to give the tickets and other people has to wait outside, and after he show a seat to you, again he has to get back to the counter and then distribute the seats, right? So in spite of that, if you distribute if you distribute the work between people, like distributing the tickets to one work is given to one person and showing the seats is given to another person. So both things will be done parallelly, right? So there is no point of people waiting outside, right? In the same way, in Java also, like there is a concept called threads. Okay, threads is nothing but it's a pathway where a particular task is done parallelly. Okay, so what will happen is when simultaneously at same time, okay, different tasks will be executed. That is a specialty of multi-threaded. Okay, so now as the distributor and the person who is showing the seat are working parallelly, as soon as he distributes, I mean there's no connection between whether he distributed or not. People will be in the queue who are already with the tickets and he will be doing his work. Right? So nobody is waiting anytime. So this multi-threaded ensures that it will avoid the idleness of the processor. Okay.
Yeah.
So that is the speciality of this multi-threaded, just to avoid the idleness. Okay, and also to perform the task simultaneously. You can tell. Okay, hence I can tell since this multi-thread parallelly performing, parallelly task performing has exists in Java. Hence we can tell it's highly performed language. I can tell.
Okay, interactive is what?
Yeah, interactive in the sense, for example, when you create some web pages, right? For example, when you create some web pages, okay. So sometimes when you click, okay, for example, you have logged in, right? When you have logged in, when you do not enter the correct password, immediately a comment will be popping out that please enter your correct password, or if your password is not meet the criteria, like it should have some capital letters, some small letters and all, right? So in that case, it will automatically pop up a message that please enter the 6 characters password or something like that. Hence, it is interacting with the users easily, right? So before there was a concept called applets in Java. Now applets is totally removed from Java because there exists some Java scripting and all for doing all the web pages, related works and all. So applets is now totally removed from Java. Okay, so because of this applets and all, I can tell because of this immediate comments given by the program. Okay, hence we can tell it's interactive language. You got my point?
Yep.
Yeah. Okay. So yeah, dynamic in the sense like it can perform in many things. Like as I said in 3 missions you can
skipped,
develop a
hello,
program.
you skipped high performance, man.
No, I have told you what I told. Since it is performing tasks simultaneously, it's a highly performed language. I said, right? This point.
Okay.
Yeah. So dynamic in the sense like in 3 missions you are you are implementing different kinds of code by different people, right? But still it was able to combine, right? So in that case I can tell it's dynamic. And also, even though I told you one statement, write once and run anywhere, right? So even though you change your hardware configurations, or you change your OS, or you change anything, but still the byte code will be giving you the same output, right? So
Right.
from this you can tell it's dynamic, right?
Yep.
Yeah. So these are all the features available in Java. Okay.
Yep.
Now I have gave a quick introduction for all these features. Let's see one by one. Okay. Okay. Now for example, in C you have idea on C language, right? Because I'll be taking the example of C language because it's a structured programming language.
Yeah.
I mean I can do that, right?
Yes.
Yeah. Okay. Yeah. Okay. So, for example, in let's go for Java only. In Java, there exists a concept called, I told you, polymorphism, right? It's one of the OOPS concept. Okay. So, what is this OOPS concept? What is this polymorphism is? It has of 2 kinds, okay, overriding and overloading, okay. It's like using the same function, okay, using the same functions for different number of times, okay. Like that, it's very flexible that in reusing also, okay. Like for example, you are using the same function name multiple times in spite of declaring it again and again. Okay, so in this overloading and overriding, we'll be using the same function different number of times. I mean, specifically, it will be like different classes or in the same class that I'll be telling you when overloading and overriding comes. Again, you'll be getting confused. Okay, so just for timing, I'm telling you as an example. So whereas in C language, you cannot do that. You cannot use the same function name another time.
Right.
But in Java, we have that flexibility. Okay, so now when you are using the same function name multiple times, for example, let's take a small example what I have taken before. See, we have to calculate the area of all the shapes, okay, like square, triangle and rectangle, okay. For all the things you can use the same function called area in Java. That is a specialty of Java. Okay, so that you'll not be confused, right? Using the same name, you'll not be confused at all, right? Hence, we can tell it is simple. Okay, And also in C there is no inheritance concept. There is no inheritance in the sense we can reuse the classes instead of creating it again and again. I think for the demo class I have explained you about inheritance. I think you remember that.
Yeah, I remember that. I
Right?
remember you showed me the example.
Yeah. So like that I have showed you how we can reuse the code, right? So that those things are not at all available in C language, whereas in Java it's available.
Hey,
Okay.
before this inheritance, you mentioned one point. Now, can you repeat that, please?
Which point?
Before inheritance, you talked about something else. Now, can you repeat that because there
No,
was some breakup.
I was telling you, yeah, I was telling you about, let's take an example of calculating the area of squares, area of shapes, okay, shapes in the sense square, rectangle and triangle, for example. Now, for calculating, for example, when you wanted to calculate something, you'll immediately create some function, right? Either in
Yeah.
C language or any programming language, you'll be creating a function and then inside a function you'll be giving the logic, right? So in the same way for the different thing, we will be creating different functions like square, rectangle, triangle in C language, right? But in Java you can use the
Right.
same name, okay, but different parameters. For example,
No, that is overloading.
yeah, sorry,
No, that you explained overloading. You explained that I understood. After that, you said something else. No,
yeah.
no.
After that,
After
what I told?
overloading and before inheritance, you explained something else. No.
I told this only, right? We can use the same function name, and you can because in C we cannot have this feature. I told you same function name can be used for all the three things. So it is
Correct.
very familiar.
Hmm?
As I told, hence it is very easy to understand because we are using the same function name, and
Okay.
then you are performing the operations inside the functions using the same function name. I told you this only. I did not tell anything.
Okay.
Okay. Okay.
What is this
Now,
no direct pointer manipulation?
yeah, that's what I was about to tell that only. My mouse got
Oh,
clicked
okay.
here. Okay. So this, you know, what is this malloc and calloc in C?
No, I forgot. Next.
Oh, okay. Okay, fine. So what is this malloc and calloc is nothing but this is a memory allocation. Okay. Whereas, for example, a small example I'll be giving you. For example, when you declare a variable with integer, okay, the size of the integer is only 2 bytes, right? So, now, for example, if you okay, let's take an array. Okay, let's take an array. Array size is some 8. Okay, like you know, no, what is the size of array? How it will be?
Yeah.
Or I'll show you in a name.
Huh?
You know, right? If you know, I'll go ahead. If not, I'll show you with a picture.
Huh?
You know, no, the size of the array, like it will start from 0 to 7.
Yeah. 0, 0, 0,
Sorry,
0, 0,
hello,
1, 0, 2, like that.
hello.
Yeah, I'm hearing.
Yeah, that is the size. You can tell that is the index of the array, right? So,
Right.
for example, if the size of the array is 8 and if only 4, okay, if you utilize only 4 indexes, then the remaining space will be wasted, right? Normally in C language, right?
Yes.
So yeah. So now what is this direct pointer manipulation is? Now in Java, what will happen is how much you wanted to use, that memory will be automatically. Now in C, for saving the memory, you should use malloc and calloc functions, okay, in order to manage the memory. Whereas in Java, it happens automatically wherever the empty space is there, that will be occupied. For example, now what will happen is in the same address, okay, in the same in the if the okay, if the value, for example, in array, if the address of the array is 0, 1, okay, in the 0, 1 there is a value called Shankar, okay, some value is there. No, for example, if another person called Shankar is there, in that space also the Java pointer will point out to that address, whereas in C it will create a new memory location and then store. Now you got the point, no? So in that way it is managing the memory automatically.
Right.
So here, see, memory allocation is dealt with pointers, right?
You're right. I understood what that. I got that.
Yeah. So this is what the pointer manipulation. Okay. You
Yep.
got. So hence in the last point also, it is mentioned that handles memory automatically. This is how it handles the memory automatically. Got it?
Mm-hmm.
Okay. Okay. Now, yeah. What I told you, what is a compiled and interpreted language, right?
Yeah.
So, as I said, your compiler will convert high-level language into a machine-level language, right? So, now, what is a special feature in Java I wanted to let you know is, now as I told you, when you compile a program, we'll be getting a byte code, right? So, what is this byte code? I just wanted to tell you what is the life cycle of the execution of a Java program. Okay, you will be knowing it now. Okay. Now there is a machine called Java Virtual Machine. Okay, this machine, I can tell. Yeah, this machine can understand the byte code. Okay, so wherever in any machine, to execute the Java program, you to execute the byte code, you should have a Java virtual machine. Whenever you install Java software, it will have JVM, okay, which is called Java virtual machine. So this Java virtual machine will understand the byte code. Without Java virtual machine, your byte code cannot be executed, okay, because JVM can only understand the byte code. Okay, so now here you can ask a question that, see, similar to C language, it is also same platform independent. No, you are asking me to install Java software and then you can run the program, right? This question arises, right, for you?
Right.
Yeah. So what is my answer to this is, now for every OS or for every machine to machine, JVM varies, okay? It's not one and the same. But still, any JVM can execute this bytecode. It's like, for example, now if anybody speak Tamil, okay, if anybody speak Tamil in other place, like in Chennai, people will be speaking Tamil, right? But in Bangalore, people will be speaking Kannada, right? So, for
Right.
example, in Kannada, if any person speak Tamil, it is understood by any Tamilians, right? It's not like only the person who speaks Tamil, only he can understand, the other person cannot understand in Chennai, right?
Right.
So it's not the same. Everybody is speaking the same language, so every Java virtual machine will understand the bytecode. Okay, you can take this example. Okay, so hence I can tell it's purely platform independent. Whereas in structured language, no, you cannot run the code because there is no virtual code derived when you execute it. But in Java, bytecode will be produced, right? This bytecode you can be taking anywhere. When you compile C program, anything will not be produced like bytecode and all. It will execute then and there itself, right?
Right.
Only a .c class file, .c file will be generated. That's it. But when you compile a Java program, .class file will be created, right? So this .class file is nothing but a bytecode. Okay. Okay. Now see. the phases of how the program will be getting executed is when you give a Java program to a compiler, the compiler will convert the a very high level language to a machine level language, and that machine level language, then that code will be sent to a virtual machine, and virtual machine will execute the program and generate a byte code, and this byte code, okay, and this byte code will be read line by line. You know what is an interpreter, right?
Right, yeah.
You want me to tell you what is an interpreter?
No, in the previous slide you told me, no, interpreter is like it interprets the byte code into machine language.
Yeah, that is there. But the basic, I want to tell you the difference between a compiler and interpreter.
Okay.
Compiler and interpreter does the same work of converting high level language to a machine level language. Okay. But still, the difference between compiler and interpreter is compiler will do a group of data together, whereas interpreter will do line by line. That is the difference between compiler and interpreter. Okay.
Then why do we need both?
Now, sorry?
Why do we need both the compiler and interpreter then?
Yeah, because because both will be there. Because, for example, when you give one set of lines, that is set of program, okay. So what will compiler do is it will compile the whole program at a stitch. See, for example, when group of people come, your performance will be less. When one by one come, your performance will be more, right? So 2 times the transformation will happen. Okay, so now in Java program, what will happen is the compiler will check for the syntax errors, okay, and the interpreter syntax errors and easily converted directly, okay. But still, the interpreter again, when Java virtual machine generates a byte code, it is again a high level language, right?
Okay.
Right, you got my point. So when byte code is generated, it's again a high level language, and this byte code, if it is converted in a group of statements directly, some things may be missing, okay. So to be careful, the interpreter also involved, and then it will convert line by line into machine level language. Okay, got it?
Yeah.
A small example is when group of people approach you, you will have a tough task. When people approach you in a queue, it is a easy task, right? This is a very good example, I can tell you.
Okay, so but in the slide you said compiler will parse the Java program and then give it to the virtual machine.
Yeah.
So, but compiler will not generate any byte code. That's what you're saying.
Yeah, compiler will not generate any byte code, only virtual machine will generate. Compiler's responsible is only to convert it into a machine language.
Okay, but once it's already converted to machine language, then why interpreter is needed? That's what I'm asking.
See, you're getting confused here. Now, I'll tell you from the beginning, okay? See, now first what compiler will do? Compiler will convert it into a machine level language. The language which virtual machine is a machine, right? It should be, it should understand what is the data user is giving, right? So, if you, for example, if you remove Java compiler, a Java program cannot understood by the virtual machine, because virtual machine can understand only the machine code.
Yeah.
Okay, you got my point?
Yeah.
Now? Okay, and next what we'll do is the virtual machine will execute and generate a byte code. Okay. You got till here?
Yeah.
You're clear till here? Okay.
Right. I got it.
Yeah. Now, what this byte code will do is this byte code can be, converted into a machine code when the program is executed for the second time. Like, for example, you are writing the code. In one machine. You wanted to run it in other machine, right? So already your program is compiled. Just to get the output, you have to convert it into a machine code, right?
Correct, correct.
So in compilation, what do you mean by compilation? To remove the errors. For example, in Java program, you miss some semicolon, you miss some bracket or something. These all will be removed by the compiler. Okay, whenever you compile, only these errors will be shown. But whereas in interpreter, what will happen is the errors like if you miss any plus symbol or if you give any wrong variable, okay, instead of other variable, these errors will be, if you go line by line, you will get logical errors. Syntax errors are different, programming errors are different, right?
Right.
So syntax errors will be handled in a group manner, right?
Right.
But whereas the logical errors, you have to go line by line, right?
Yes,
Okay.
yes.
For example, a small example. Now you know this method in C language, calling function and call function, right? Right. So now what will happen is calling function will call the other function which is above the calling function. Okay. For example, wait, I'll tell you in small example in a notepad. See, for example, add function is there. Okay. I'll increase the font. Okay, now add function is there. Okay, now what can we tell is int a, int b. Okay, now we are there are some statements here. Okay, some statements, let's say some statements are there. Now what will this function will do is, this function will call the above function. Okay, okay, now what will happen is, now it is calling the, yeah, now the below function is calling the above function, right? This is a calling function, okay, and this is a called function, okay. So now when the pointer comes here in a C language, when the pointer comes here, the processor will be knowing that this function is calling this function, right?
Right.
Yeah.
Yeah, I'm here.
So when you,
right, yeah.
yeah. So if you do it in a grouping manner, you can't understand the logic, right? When the pointer will go to this line and then check what is this add and what does this semicolon mean, it should verify the syntax of the meaning of it, whether the function is calling or whether the function is called or something. So for such things we use interpreter, because this should happen line by line. Okay, high levelly, if suppose if you miss some bracket here, okay, flower bracket here, then that scenarios will be done by the compiler.
Okay.
Okay, you got my point?
Yeah.
Yeah, now it's clear, right? You don't have any confusion, right?
No, I got confused because if I go back to your presentation.
Yeah, I went back. Yeah, you are able to see?
It's still coming up. Yeah, now it came up. So what I'm saying is Java compiler produces an intermediate code known as byte code for a machine known as JVM. Okay. Okay. Now that means compiler is producing the byte code, right?
No. Virtual machine is producing the byte code.
No. See this?
The code which is intermediate between compiler and the virtual machine is a byte code, right?
No. What is your first sentence in your
See,
screenshot?
okay, see, I'll tell you. Now, the first sentence mean that now Java compiler produces an intermediate code, right?
Known
Right?
as byte code.
Yeah. This byte code, in the sense, the Java virtual machine will be generating it at the end. Okay, I can tell it's an intermediate code only. No, you did not get my. Okay, you don't get confused. Simple thing that the Java compiler will convert it into a machine level code, and that code will be executed by the virtual machine. Okay, so it is acting as an intermediate code between virtual machine and the compiler. You got my point?
Yeah.
Okay, byte code in the sense which is in the form of a machine language. Okay, now you are clear?
What you said?
Byte code in the sense which is the in form of machine language. You got?
Yeah, but no. What the slide is what it's saying is, okay, that compiler is generating the byte code for the machine known as JVM, and then JVM will take that and generate the machine code. That's what the slide is saying.
Okay, you got confused with that. Okay, fine, I agree. Okay, actually the thing is, what I meant in the form of is, it is an intermediate code between a virtual machine, because Java compiler will produce a code after generating it into a machine level language. Virtual machine, what it will do is, it will take that code and then execute it and generate a byte code actually. Because see, in the previous slide,
Can you redo this slide?
see,
Can you redo this slide
the
and show it
previous
to me?
slide JVM, sorry, hello,
Yeah, tell me. I'm here.
Shankar, you are able to hear me?
Yeah, I'm here.
Yeah, okay. Yeah. So don't get confused, okay? Don't get confused. Compiler will generate a machine code, okay? And the virtual machine will read that code, and then it will execute, okay? So that code will be treated as a byte code. Simple.
Okay. Once the byte code is generated, then Java interpreter will interpret that and generate a machine code. That's what you're saying.
Yeah, that's what. Okay, you got it?
Yeah.
Okay. Next, object-oriented programming. Okay. So, what is this object-oriented programming? Is I said you in Java.
This is last slide, huh?
Yeah. You have any question?
Swati, is this last slide?
Yeah. This is.
It's already
No.
last.
There are few more slides. There are
No,
few
for
more
today-
slides that will continue. Yeah. So, you want me to continue tomorrow?
Yeah. No. After this slide, we'll continue tomorrow. Okay.
Okay, fine. So next thing is object-oriented programming. Okay, so this I said you in Java everything is everything is developed in form of objects. Right? Through objects itself we achieve many results. Okay, so this classes and object, the format of classes and objects will be for any program or any logic or any requirement. The program will be in the form of classes and objects. Okay, so hence I can tell Java is a pure object oriented programming. Okay, and I can tell we can reuse the objects, we can reuse the classes anytime. Okay, and any number of times also I can tell. Okay, so it's very easy for us to understand and save our time. Instead of writing from the beginning, we can just reuse the class which is already existing. Okay, hence I can tell Java is a pure object oriented programming. Okay, got my point?
Yeah.
Okay. So next few more features are there. Okay, like platform independence and robust.
Yeah, that will do tomorrow. Okay.
These features we'll discuss tomorrow.
Yeah.
Okay, and Yeah. Tomorrow 7:30, right? 7:30 IST, right?
Yeah, and send this
Hello?
presentation, okay?
Yeah, I'll be sending you after completing this whole topic, okay?
Okay, okay.
Okay, after completing this whole topic of free features and all, then I'll send you.
Okay.
Okay, and the other thing is tomorrow 7:30 only, no? Or
Right.
you want 7:30, right? Okay.
Yes.
Okay, fine. Thank you.
Thanks, man. Thanks a lot, man.
Okay, thank you.
Thanks, man. Bye.
Okay, bye. Have a good day.
Hey, you too, man.